Notice that my title is a little different. The other ones are using economics to inform socio-environmental research. I'm using socio-environmental systems to inform economics, to inform ecological economics. So I want to build an economics that's based on solid science. It's based on understanding of social and environmental systems. And ecological economics is trying to do this in theory and practice. So first of all, my career goal, which I don't really expect I'll achieve, but it's what I would be working towards, is this, to contribute to the design of sustainable and just ecological economy. I really do think we need to fundamentally transform our economic system. I think most of our environmental problems are driven by economic activities and driven by our poor understanding of how economic systems work. And as I'll make the case, our environment continually evolves, our society continually evolves. We need an evolving economic system to adapt to those changes. What made sense in an empty world doesn't make sense today. In an empty world, I mean with fewer people and less resource use. So my methods, my primary methods, and this is a little bit tongue-in-cheek, but systems analysis through observation and synthesis, I obviously can't write this into a grant proposal. I always have to have quantitative methods in my grants. But if you think about it, what did Adam Smith, Karl Marx, and Charles Darwin use as their methods? I'm not putting myself on par with them, but I'm saying that their methods were observing a system and coming up with really important understanding of that system. Darwin, no way could he get an NSF grant because he's just not quantitative enough. Yet those are incredible breakthroughs in science. So my current research projects, these are the ones I have funding for right now mostly. Serendipitously, my most recent grant is to hold a workshop conference on a research agenda for ecological economics. So I will go into exploring what ecological economics is. Another one is agroecology and ecosystem services in Brazil's Atlantic forest. So I'll talk a little about how I apply some of these ideas to a case study. Another one is food security on a full unequal planet. And I'm looking at this as the economics of essential resources with the idea that if economics is going to get anything right, it's got to be how to allocate essential resources, those things we need for our survival and which have no substitutes. That's the one thing I want to try to get right. And then look at economic institutions for addressing prisoners' dilemmas, which widely agreed across the disciplines can only be solved through cooperation. People pursuing their rational. Does anybody here not know what a prisoner's dilemma is? And I can cover it when I get to it. I probably won't get to all of these. And then finally, monetary and financial systems for a finite planet. So this is, I think, a big topic, hugely ignored by economics. I think we have a really weak understanding of monetary and financial systems. But I'm sure I won't get to that today. So to start out with on this research agenda for ecological economics, what defines ecological economics in my view, there's two parts that define it. One is our worldview, our paradigm of what is biophysically possible, of how life exists. And that's what this central axiom is. And it's the economy embedded in society is a continually evolving physical subsystem of a complex, finite global ecosystem subject to the laws of physics and ecology. That summarizes the biophysical view of ecological economics. But from this emerges goals, and our goals are distinctly different in that our primary goal, which I'll get to later, is ecological sustainability, which can be a very, a broad term, but basically it's ensuring that the economic system doesn't overwhelm the capacity of the global ecosystem to reproduce itself and provide vital ecological functions. And if we live on a finite planet and there's limited resources, then we really have to think about just distribution. Who is entitled to those resources? And the third goal would be, how do we meet basic human needs with minimal ecological cost, which is a ratio, an efficiency ratio. So you can call it allocative efficiency, but we define efficiency dramatically different than conventional economists define it. And as I go through here, I am going to be, saying things that, so people can interrupt me. I will be saying things that are controversial, and but I'll be trying to back up what I say with evidence from the field, from the literature, so the things I might say about conventional economics. And again, I'm not saying that conventional economics, it evolved. It emerged a couple hundred years ago when situations were radically different, when the population on the planet was less than 1 billion. So we had like 1/8 the population with 1/20 the consumption per capita. which essentially means our economy, and I don't know about I know we had 1/8 the population, I don't know what our per capita consumption was, but the size of the economy has expanded probably by a factor of 100. That puts us in a radically different situation, which is now being called the Anthropocene, where human impacts on global ecosystems are on the scale of geological forces. We're changing the chemistry and physical geography of the planet in a profound way. So the first point I want to make is that economies are evolutionary systems continually changing. So we started out, for the first 200,000 years, a hunter-gatherer economy. Small, very egalitarian bands, really strongly based on cooperation. Lots of evidence that if people tried to accumulate and take more for themselves, they were ostracized, thrown out of the community, and couldn't survive. Another important part of this thing, if you think about, these are nomads. They traveled like 20 miles a day, and they had to follow the food supply. And that meant they couldn't accumulate more than they could carry. So this idea that humans always want more and more and more, for 200,000 years, accumulation would have meant death because you couldn't follow your food source. So we really didn't, so you have to at least acknowledge that in your views of economics about how much accumulation is necessary. But lots of great research on egalitarian, really unhierarchical, lots of sharing. But from there, so 10,000 years ago, and this is kind of a big thing to think about. So we came out of Africa 50,000 years ago, dispersed around the globe. And for the first 250,000 years had very similar technologies. Hunter-gatherers occasionally every 20, 30,000 years develop a new way to nap an arrowhead. 10,000 years ago, we reached the Holocene. Suddenly, climates became stable around the planet. And simultaneously, in at least 7 different locations around the planet, we developed agriculture. And everywhere we developed agriculture, we developed new social hierarchies. We developed division of labor, new political hierarchies, new economic systems, religious hierarchies. So a whole suite of social cultural adaptations accompanied the Holocene, and so cultures that had been incredibly similar for 200,000 years hadn't been in contact with each other for 50,000 years. When the Europeans went to the Americas, they could recognize the economic, political, and religious institutions that had all emerged very recently and simultaneously. So the idea is that our environment has a huge impact on the evolution of human culture. But what was distinct about this is suddenly we had denser populations, we needed to have division of labor, we developed enough surplus to sustain a political class and a religious class, and all of these characteristics emerged, and for the first time we came to cooperate on a larger and larger scale, accumulating more and more surplus, and really, really important. I don't have time to go into this in great detail. Then we developed the industrial economy. So this is 200 years ago when we developed the use of fossil fuels. So we transitioned from renewable resources to non-renewables. We expanded we could communicate with far more people. We could have bigger trade, much, much, much larger populations. But accompanying this, we use non-renewable resources that created novel chemical compounds to which our ecosystems were not adapted and were incapable of processing. So this is a huge transition. And, Adam Smith's Wealth of Nations was 1776, explaining the origins of the capitalist system. James Watt's patent on a more efficient steam engine was 1776. And the steam engine was first used to pump water out of coal mines. So the idea is that the capitalist economy and the fossil fuel economy emerged at exactly the same time. And people talk about the magic of the market and producing more and more resources. A barrel of oil is the equivalent of 20,000 hours of human labor. Assume we lose 75% in conversion. A barrel of oil is 5,000 hours of human labor. A $50 barrel of oil is competitive with labor at anything more than 1 cent per hour. So this is an insane source of energy. And I think we should have the National Push Your Car to Work Day so people can appreciate how much energy is worth. And then, more recently, is we really developed a financial economy. So, and I won't, maybe tomorrow when I have a 5-minute spiel, I'll talk a little bit about money. But money, this idea that, so one of my views is that why humans dominate every other species in terms of our ability to reproduce, et cetera, is our ability to cooperate. So small bands of hunter-gatherers, they acted like an entity of 50. They could take down mastodons, they could hunt out, they could wipe out all the giant megafauna. We became agricultural societies. We could band together in groups of 5,000, 10,000 easily. And we developed nationality. So before, hunter-gatherers, there's this thing called Dunbar numbers. You can cooperate with people you can trust. Small numbers, 150, 200 people. We develop nationality and religion. Suddenly you trust much larger groups. You develop money. You can cooperate with people on the other side of the planet you don't know or trust if you trust in money. But money, what I'm talking about is evolutionary change. You know, as I mentioned this yesterday to some people, when I was doing my PhD, stocks were held on average for like 4 years. Now they're held on average for 30 seconds. We have an economy which is primarily based on finance. So when we had in the 1980s, banks loaned money into existence to invest in productive enterprises. Now almost all money is loaned into existence to buy existing assets, not creating new wealth, but driving up the value. And this takes a lot to talk about, but it's a really profound, this financialization of the economy. We've also had another evolutionary change of an information economy. So before we were talking about scarce resources, I eat food, it's not available for others. I burn fossil fuel, not available for others. Information improves through use. Radically different physical characteristic. So, the characteristics of the resources are important. And now I would argue we are heading into an economy where where our economic activity is wiping out the planet's ecological capacity to sustain human civilization, if not life. We're not threatening life on Earth. Life's always going to bounce back. We wouldn't exist if there hadn't been previous mass extinctions. But what we need is an ecological economy. So as systems change, our economy has to evolve. We have to evolve an economy compatible with a finite planet. And the point is that the rate of change is accelerating. I would argue that this financialization of the economy is a radical change. It really is a fundamental, I'll get a little bit back to that later. We're not calling necessarily for more radical changes than these other ones. We're just calling for changes in a different direction. So when people say our views are radical, I would argue that economies change in radical ways ever faster, and we just have to direct the change in a more acceptable direction. The point is that the economy has to adapt to ecological constraints like climate change, like population growth. So this is interesting because, population, big deal. The red is human populations. The green is populations of wildlife, and the blue is the populations of domestic animals. So it's not that human populations are so big, it's human populations and what's required to feed us has completely wiped out much of nature. So we have to deal with those ecological constraints, but we also have to meet basic human needs, many of which are unmet right now. There's over 1 billion people, or there's close to 1 billion people who can't get enough food, and many others who don't have access to clean water or enough energy or other resources for a good life. So our challenge is to develop an economy that's ecologically sustainable and meets basic human needs on a finite planet. And and as you notice, I said that it's a physical system. So the economy is a physical system. And really quickly, I just want to talk about Donella Meadows. I mentioned this yesterday. She has this great article on leverage points or places to intervene in complex systems to affect change. And the two biggest ones she talks about is changing the paradigm. And in my view, that is what is biophysically possible, but also what is behaviorally possible. We have to change the paradigm about humans and human behavior. So I'll talk a little bit about that. And the other second most powerful lever, she says, is changing the goals. What is our economy striving to achieve? So I'll focus a little bit about how we change the paradigm and change the goals as part of ecological economics. So to begin with, I said that the economy is a system subject to the laws of physics. Two basic laws of physics, really important. You can't make something from nothing or nothing from something. Every single thing the economy produces requires raw materials that come from nature. Even information, knowledge, has to be embodied in some kind of physical substrate to be preserved, or even our brains, run on the power of belief. We need food to maintain our brains as that physical substrate. So all natural resources come from nature, and it takes energy to do work. And 85% of our energy is fossil fuels, so we are using energy and raw materials to create economic products that always break down, wear out, fall apart, return to the ecosystem as waste. At the same time, all the energy we burn, energy can't be created or destroyed, And that also returns to the ecosystem as waste. And these are novel products which our biological systems have not developed a capacity to absorb and recycle. And maybe they will in 1 million years, but mammalian species don't last 1 million years. So we have limits to that. So it's the laws of physics, and the idea of the second law of thermodynamics is that disorder increases, useful energy becomes waste heat. And an extrapolation of this, which is not really, physicists will argue that's not really a law of entropy, but the same idea that energy becomes disordered, useless waste. These physical products become disordered, useless waste, kind of like an analogy with the entropy law. We also have to think about the laws of ecology. So those raw materials we transform in economic products, they alternatively serve as the structural building blocks of ecosystems. And when you remove structure, you lose function. When you spew waste, you lose function. And there's a particular configuration of that structure. You take the plants and animals and water and minerals and it creates an ecosystem. And that ecosystem has these complex emergent processes that are essential to all life. And so this is, when we remove that structure and throw back waste, we degrade those ecosystems. And this is an unavoidable trade-off. So there is no economic production that does not use energy or raw materials in some way, and that means virtually all economic activity has an associated negative cost on global ecosystems. When our economy was very small, human populations were very small, that was a negligible cost, could easily be ignored. Now I would argue it is what dominates the economic scarcity issues or the dominant thing we have to address. So the implications of this for economics, and these are big, I think. So one is that this endless physical growth of the economy is impossible and undesirable. It doesn't mean we can't have qualitative improvements. It doesn't mean we can't have a better quality of life. I would in fact argue that our current level of consumption undermines our quality of life. That we have become a nation that is unhealthy, overweight, because we drive our damn cars everywhere, we eat too much, we consume too much, it makes our lives worse. Enclosed in our cars, we don't interact with people. This idea that, but people say, well, what about technological progress? We can continually have technological progress. Well, this is a very interesting thing. In complex systems, every complex system, they tend to grow, but they reach a level where they stop growing, like the human body, like, even corporations, everything. And so the idea is that as the economy becomes bigger and bigger, new technological progress can be a real transformation that allows the economy to grow more, but to keep that up, you need faster and faster technological progress, and often that has really unacceptable results. And my view on this is we don't want to bet the world on things that don't yet exist. And I'll talk about uncertainty and novelty and the problems with assuming that technology will improve. The other thing is, most economists want exponential growth. So let's say we could do this purely in a non-physical way and have exponential growth of well-being. Exponential growth, that means the same doubling time. That means our happiness levels would double every generation, let's say. Eventually you reach a point where it's relentless bliss. I mean, you just can't have, it's even psychological benefits can't grow exponentially. But the other interesting thing, in economics, we always talk about efficiency or optimality. What we mean is Pareto efficiency. Pareto improvement is a situation in which at least one person is made better off without making anybody else worse off. And in theory, a free market leads to a situation in which there's no way to make somebody better off without making anybody else worse off. And we always want to seek Pareto improvements, and economists understand there's all sorts of problems with coming to this Pareto efficiency. But a Pareto improvement is making somebody better off without making anybody else worse off. But if you accept that you can't do energy without using raw material, you can't do work without using raw materials or energy, you can't do economic products, all economic production is degrading ecosystems, and those things like climate stability, all these globally distributed benefits are being degraded by our economic production. So there's nothing I can do that's going to make me better off without making somebody worse off. And if it's based on economic growth or using more resources or more energy. So this Pareto efficiency really becomes an irrelevant criterion because everything Me giving this presentation is burning energy that is putting CO2 into the atmosphere that is making Africans worse off. So how could we use this as a criteria? I mean, all economic activities degrade ecosystems. So the other thing is that individual choice is often impossible or inappropriate. I can't choose as an individual the level of climate stability I want, the level of clean air I want, the level of clean water I want. And very often when I'm allowed to have my individual choice, I choose things that are going to cause harm to others. So that this individual choice, it's often, for some cases, it should be very desirable, but the idea, it's often impossible and often inappropriate. So those are some of the implications of the finite planet and laws of physics and ecology. I also want to talk about complexity. And so I'm not an expert in this area, but I've read a fair bit. One of the things about complex systems, they have enormous numbers of positive and negative feedback loops. So this is just a little thing of all the feedback loops required to attain homeostasis in a human body. So a huge number of feedback loops just to maintain homeostasis in my body. You have similar, to sustain homeostasis in a physical system, ecosystem requires a huge number of feedback loops as well. And when I say homeostasis, I don't mean by this that an ecosystem persists forever any more than I mean that my body persists forever. So homeostasis has a time frame involved. We're going to be a sustainable economy is limited over time. My homeostasis in my body is limited over time. Ecosystems evolve. But you need enormous numbers of feedback loops to maintain homeostasis. So how does this reflect on our economic system, the implications? So, homeostasis requires innumerable feedback loops, and we didn't go over this, but what I would consider the core pillar of mainstream economics is what they call a Walrasian general equilibrium, is that price is the sole feedback loop needed to drive a system to homeostasis, to economic equilibrium. And so most economists believe that the price mechanism, so as a price goes up, my demand goes down, and there's an incentive to produce more supply, and those are negative feedback loops driving the system to homeostasis, to equilibrium. And we assume that this is going to drive our complex ecological economy to equilibrium with a single feedback loop of price. And this is a bit of an exaggeration, obviously, for people at the frontier of the field, but you look in any economic textbook, and even in my PhD defense, one of my advisors said, I met this guy who doesn't even believe in general equilibrium. And I thought, oh my God, I better shut my mouth because this is my defense. And if he had so much disregard for anybody who doesn't believe in equilibrium. And and it is widely accepted. This is like one of the core beliefs. The chair of our econ department was just saying that, equilibrium theory, when I get back, the econ department's purging a heterodox economist because he doesn't teach the doctrine. They said he disagrees with equilibrium theory, which is the cardinal sin among economics. And I just don't think that's possible if we believe in complexity. So this is not to say that prices are a really powerful negative feedback loop, incredibly useful, but only one of many. And I'm sure the economists here would totally agree with that. But that's not what they teach in the mainstream at all. And so one of many useful feedback loops, but also to recognize that prices under certain conditions can be a powerful positive feedback loop. So all of us know about market bubbles, about the bubbles in land prices, about the stock market bubble. These stock market will crash. I mean, the value of the stock market since 2009 has increased by 300%. The productive capacity of those corporations has increased by about 30%. So we've seen a tenfold, a 10 times greater increase in the value than the price rather than the value. That can't happen. So we have to be really cautious with what prices do. So another important point about complex systems is thresholds. So ecosystems tend to have thresholds where you can perturb a system and it remains resilient within a range, but you push it too far and it collapses. So the Amazon refilters, so the torrential rain falls on the Amazon, hits the forest canopy, breaks up into a fine mist, is absorbed by the ground, reabsorbed by the trees, evapotranspires, forms clouds, falls on the forest again in a system. You clear some of the forest, and more of that rain hits the ground, compacts it because there's no roots, flows into the rivers, is flushed from the system, is not recycled, and you do not have enough rainfall to maintain the Amazon anymore. And then you can flip into a savanna state, or something hopefully this desirable. But really good research is showing already the deforestation of the Amazon has reduced the recycling of rain and makes it less resilient than it was. And once that you're in that new system, it can be incredibly difficult to flip back into the old system. And these new systems, we don't really know what they will be. I'm showing this nice conversion to a beautiful savanna, but who knows what the hell will actually happen. So we have these ecological thresholds. We also have this great research on planetary boundaries. And this is a study by, I forget, in Stockholm, but Rockstrom and a bunch of other people. What they tried to identify was these planetary boundaries that if we exceed them, we risk catastrophic change in our entire system. And the biggest one they identified is biodiversity loss. The next biggest is nutrient cycling with nitrogen flows. The next biggest is climate change. And then you have phosphorus flows and change in land use and global fresh water, ocean acidification. One thing I want to call attention to on these, most of these, the major culprit is agriculture. So agriculture is absolutely essential. We need it to survive, but it's the biggest threat to global ecosystems. So the point is, these are where we have exceeded the potential for catastrophic thresholds, collapse, switching the system into something else. So we have these ecological thresholds, but we also have economic thresholds. And economic thresholds are most easy to think about with essential resources: food, water, energy, ecosystem services. They're essential to human survival. They have no substitute. I don't have enough. It's very easy to discern what the ecological or the economic threshold is for food. I don't have enough calories to maintain my body. For somebody my size, probably like 1,700 calories a day. You die. That's a pretty big threshold event. And the same, you need water, energy, all of these things. You need these. So a critical threshold is, yeah, you know what? This, no, it's, I hit threshold. And actually, it's my crappy battery. So this will just take a second. I don't think it's dead. Yeah, my battery is, it'll go to like, say, 70% full and then just collapse instantly. So this will just take a second. I came prepared, fortunately. And let's hope it bounces back rather than resetting everything. Sorry about that. I should have done this to begin with. Usually it gives me more time than this. This was like a record. Yeah. So I do have this tendency. To just spew a lot of information too fast for people to digest. So feel free with any questions. But critical thresholds, So there's these. Actually, I probably should just remove that. And this is jargon, big time jargon. But when things are essential, they have what's called inelastic demand, and that means that price increase has little impact on demand, or vice versa. A small change in quantity leads to a large change in price. And this is, for example, when there was a small diversion of grains to ethanol production and drought that somewhat lowered grain production, 2007, 2008, again, 2011, 2012, you see the prices double or triple. Or when fossil fuel during the oil embargo, is a few percent decrease in supply, prices tripled. So when you have this inelastic demand, tiny changes in price, tiny changes in quantity lead to huge changes in price, or large changes in price hardly have any impact on demand. We're going to try to eat as much as our basic needs, no matter what the price. And what that means is that, the price mechanism is relatively weak. So in economics, we have a demand curve in economics is the marginal value of additional consumption. So what we see is if we're consuming, like Americans, 3,750 calories per person per day, the marginal value of additional consumption is arguably negative, but certainly very, very low. On the other hand, if we're like Eritrea, consuming 1,550 calories per person per day, the marginal value is immense. And so we have these thresholds. You go below a certain level and you're going to die. So what we have is rich people have a very low marginal utility for food. Middle class people, pretty low too. Poor people have a high utility. And then the destitute, it's almost an immeasurably large utility. So the point is, though, that your marginal utility becomes immeasurably large as you approach an ecological threshold. The point I made about A supply curve in economic is the marginal cost. So I mentioned that agriculture is the biggest threat to global ecosystems. So what's the marginal cost of producing food? Well, it's the labor, it's the capital, it's all your chemical inputs, et cetera, but it's also all those ecological costs. And if we believe the planetary boundaries discussion, the marginal cost of agricultural production, or the marginal cost of any production in a predominantly fossil fuel economy, we're exceeding planetary boundaries. Our marginal costs have become immeasurably high. For the billion people who don't get enough to eat, the marginal benefits of additional consumption are immeasurably high. So those people who aren't meeting their basic needs. So we are in a situation where, you all know in economics, supply and demand curves intersect. I would argue we're in a situation where the marginal costs of current economic activity are immeasurably high. The marginal benefits for those people who don't have enough are immeasurably high. We have non-intersecting supply and demand curves. This is a different situation than we've been in, and something we have to address. So that's, a little bit radically different than your conventional supply and demand curves. Implications of this. So again, this is about threshold. So this is like a definition of a threshold. Increasing the value of a control parameter beyond some critical point results in a phase transition, a radical change in the system's qualitative features. So I am arguing that if that planetary boundary information is right, the biodiversity loss, the climate change, the nitrogen emissions, all of these things are taking us beyond some critical points. They're going to result in a phase transition, a radical change in the system's qualitative features and the qualitative features of our economy. We need to develop new economic systems to address those radical changes, or ideally to take us back beyond those thresholds. But that also requires a radical change in the economy. So the point is, economics, it's considered, what they often refer to neoclassical economics as the marginal revolution. It's all about marginal analysis. This is the diamond water paradox. Why are diamonds worth more than water? Because economics doesn't focus on use value. Use value, what's the total use value of water? It's infinite, immeasurable. But it focuses on marginal value, which is the exchange value, which is the value of one more unit. And actually, one more unit of water to me would be very appealing if somebody could pour me a glass. But it's still marginal, it's not infinite. And so economics is all about exchange value, about marginal value. But once we have reached the point where there are these critical thresholds, we're not talking about marginal change. There is a level beyond which, when you deforest more of the Amazon, it does not recycle enough rainfall, it completely changes. That's a use value. We have to look at the total value, not just the exchange or marginal value. And again, that's a huge difference. And economics has to adapt to the changing circumstances. So now what I'm going to do is very quickly switch to some of my research and apply these theories to Brazil's Atlantic forest. And I'll go through this pretty quickly before I get back to more of the theory. So I'm working with agroecologists in Brazil. I'm in Santa Catarina, and we're looking at the Atlantic forest ecosystem, small family farmers, and the provision of ecosystem services. So just to give a quick overview, so this is Brazil's Atlantic forest. The yellow is the original extent, the green is the current extent. Red is where deforestation has occurred from between 2008 and 2012. So what you see is this ecosystem has lost 85 to 91% of its forest cover. My project is here in Santa Catarina, which still has about 25% of forest cover. So this is the highest recorded terrestrial biodiversity of any system. It's broken down into 245,000 fragments, 83% smaller than 50 hectares. How much deforestation has occurred depends on how large a fragment you consider to be forest. Is one tree forest, or is that just a fragment? So 2/3 of Brazil's population lives there. They depend on the ecosystem services it generates. They already had, in the 1850s, they had a crisis in Rio where they deforested their watershed. It's the first major successful reforestation project I know of for ecosystem services. Amazing job. You ever go to Brazil, go to Tijuca Forest. It's spectacular. A little bit dangerous, but spectacular. And Rio, I guess, is a little bit dangerous. And so the ecologists estimate, by analyzing all these fragments, they've concluded that if your forest falls below 30% cover, there's an ecological threshold where you have massive die-off in biodiversity. When you lose your biodiversity, your forest can no longer sustain itself. You lose all these ecological functions. And so basically, if we don't double forest cover in the Atlantic forest, the system will collapse. We've already passed a critical ecological threshold. And what we have is there's so significant time lags. They call it an extinction debt. You lose your forest ecosystem. It can take a long time before you get the extinction, which means there's a huge potential to transition to a new system, but a brief window of opportunity for action. Perhaps if we intervene in time, rebuild the ecosystem before it collapses, we can deal with it. So Brazil has a forest code. I don't know if you have followed this huge controversy. Their forest code originally mandated reforestation of critical ecological zones and additional areas that would have led to a 30% cover in the Atlantic forest, which according to the ecologists would have been enough to sustain the system. In 2012, they weakened it. They made it so it allows much more deforestation. So it's no longer adequate. But 98% of forest remnants are on private property, so we got to restore the forest. We got to work with private landowners. In the area where we are, 87% of those properties belong to family farmers, and they produce 87% of the food for the state, and which actually is buy local in Brazil. That's your only choice. You're always buying local fruits and vegetables. And 44% of the land. So it's really, really important for the local economy. There's an economic threshold in the short term, is that we're working with these small farmers. If they comply with the forest code, they're going to lose so much of their arable land that they're going to be driven into poverty. So you have this economic threshold of poverty. They would leave the land, then go live in the favelas. They would. This is just a typical property. You can't see it very well, but the forest code mandates 30 meters of forest on either side of rivers. It just shows a totally deforested property. It doesn't comply with the forest code at all. So farmers refuse to comply. They can't afford to comply. So you have this huge problem. But you have another economic threshold in the long term, that farmers, more than anybody else, depends on those ecosystem services of pollination, water regulation, pest control, all these things. And this is pictures from 2009 when I went down there, just before I went down there, of devastating flooding. And where the landslides, like 92% of the landslides, I think it was, occurred where they had no forest cover. So, clear association between ecological degradation and these catastrophes. So they'd have reduced food production and catastrophic flooding, infrastructure loss, et cetera. So, in the short run, if the farmers reforest, they're doomed. In the long run, if they fail to reforest, they're doomed. So what do we do? So our project is basically agroecology and ecosystem services. I'm working with a partner who for the past 20 years has been working closely with these small family farmers. I've been with them for the past 9 years. So it really is, it's participatory action research, working very closely with the farmers, finding out what they want. It's an area that had been doing major tobacco production, totally depleted the land, and then tried to shift to extensive cattle production, but that further depleted the land. My friend is an agroecologist, stepped in and helped them do this rotational grazing that actually increased profits for farmers and reduced ecological costs, sequestered more carbon, all these benefits. It was really a win-win situation, but not enough because it doesn't comply with the forest code. So then we moved to this high biodiversity silvopastoral systems. You can't see the images very good, but so the farmers get shade and windbreak, and this is it's a hot climate. When we were planting one of these things, everybody is standing under the shade, and the farmer says, "See, all of you want the shade, so do my cattle." So the farmers want these for the shade. But also, we're planting native species. So one big one is Euterpe is one of the most threatened species in the Atlantic forest, cleared for heart of palm. And they've just realized that it also produces a berry extremely similar to its cousin, Euterpe oleracea, which is acai. I don't know if people here have had acai, but this is actually supposed to be healthier, bigger berries, easier. We're also producing, this is one of the fastest growing trees in the world, fixes nitrogen, leaves provide fodder, it flowers in the off season, so it's great for honey production, good timber, and other species. So we're trying to produce native non-timber forest products, and some for charcoal and timber as well. And wild bees are included as pollinators, and so it's developed with farmers. We work very closely with farmers in developing all these systems. And this just shows the palm trees. They're a keystone species. The wild bees, that's me sucking, they're stingless wild bees. I'm not snorting cocaine, I'm sucking honey out of a wild beehive. And this just shows some of the systems again, and the fact that it's a keystone species, really essential for a whole diversity of animals, which would also could attract ecotourism, stuff like that. Just more of the landscape. So now we're moving on beyond this. So that's the high biodiversity silvopastoral systems. We're also implementing multifunction riparian forests, and we need a way for the farmers to pay for this. So our goal is to actually not just to comply with the forestry code, just to exceed the forestry code using agroforestry systems with native species. Farmers don't have the capital and technical assistance to do this. So what we've developed, we've been working closely with the state policymakers, with the farmers, with NGOs, to develop a payment for ecosystem service project for agroecology, but it's a modified one. So most payments for ecosystem services pay farmers to restore land to forest. But again, if you're looking at this planetary threshold, if we take land out of food production, put it into ecology, that's going to reduce food supply, which will cause cost to soar, which will lead more people to starve. So we're really looking at ways that we can continue food production while providing ecological benefits. And the payment for ecosystem services typically is an annual payment every year for doing this. So you can't count on any kind of long-term payments. They have financial crises all the time. So what we did is we met with the Secretariat of Agriculture, the Secretariat of Sustainable Development. We got them to agree to basically cover the upfront cost of adopting these systems. And if the farmers maintain the systems, 50% of the debt is forgiven and they pay no interest. So it's really affordable because with inflation and everything, so it's affordable for the farmers. And the irony of this, though, we've been working on this for like 8 years together. My buddy's been doing it for 20 years. It was last September we actually got the state government to agree. We presented our information, presented our really good research showing all this and that. And they said, well, we can't do that because the political party in power in that town you want to work in is not our party. It's the left wing, we're right wing. And we said, but the vereador, the city council guy we're working with, is your party. They said, oh, okay, then we can do it. And totally not interested in ecological benefits. He wanted an on-the-ground project to show for the upcoming elections because he's got, wants to be like move up into politics. So all our research was pointless, but fortunately we had good connections. We made good ties with the guy. Like I'd gone out drinking with the guy a few times and stuff. And so those personal ties mattered a lot more than anything else. But anyway, so that's one quick application. Again, I'm like not going into details of methods or anything. it's a quick overview. But I want to go back to the research agenda and the implications of the central axiom of EE. And I don't know, so I started it, there was a delay in starting. I don't know, I could. Go for another 10-15. All right. So another huge thing I think that we have to accept is irreducible uncertainty. So a lot of economics is modeled on risk, which means we know the possible outcomes and the probabilities of each. Alina and my colleagues here, I'm sure, can tell you ways we're addressing this. We're not so dependent on that anymore. But a Nobel laureate from a few years ago, Eugene Farma, I think his name was Eugene, he basically said that all the core ideas of economics were invalid if we did not have certainty equivalence. So a lot of the core theories depend on us knowing the future with some degree of precision, or at least the probabilities. And I would argue there's ecological uncertainty. We go past a threshold, we really don't know what's going to happen. And we don't know where those thresholds lie. We can kind of estimate that you deforest the Amazon beyond a certain point, it's going to collapse. Or if we spew more CO2 into the atmosphere, we're going to get runaway climate change. But we don't have very exact measures. There's technological uncertainty. What new technologies will come in? And it's impossible to predict a novel, innovative, breakthrough technology ahead of time. The reason I have a picture of a black swan is it used to be in the 19th century, or maybe it's 18th century, a black swan was talked about as something that's absolutely impossible, never occurs, it's just an absurdity. Then they went to Australia, and it turns out in Australia they have black swans. So black swans are these high impact, unlikely events. but they do happen, and they tend to have the biggest impacts on society of anything else. So ecological and technological black swans, totally unforeseen events, and they're tremendously important and totally unpredictable. And they tend to have power law distributions. And a power law distribution means that certain events occur. So it's a normal distribution is you have your mean and things tail off. A power law distribution for like income is a power law distribution. You take, and one good way to think about it, let's say we took the average income of everybody in this room. And this is why per capita GDP is such a stupid measure. We take the average income of everybody in this room, and then first we take the average height of everybody in this room, and then add the tallest person in the world. Average height barely changes. We take the average income of this world and add the richest person in the world. None of us matter at all. It's only the single individual that matters. And that's the idea behind these power law distributions, that single events are so wildly important, they overwhelm the average. That's kind of poorly explained, but they're omnipresent in nature. And it seems to be that these, the more novel events occur with increasing rarity, but increasing impact as well. We also have very limited substitutability. And this is what I was talking about before, fund service stock flow. So a stock flow, again, a flow that can accumulate into a stock is a stock flow. So these things can accumulate. I can chop down a forest and accumulate all the trees in a yard. And again, sorry I already explained, but they're physically transformed into economic products. They're used up. We can use them as fast as we want. They can be stockpiled. These would be raw materials or, so raw materials in economic production or ecosystem goods and fossil fuels all have these capacities. Fund services, what I was calling basically a form of capital, they're not physically transformed. They're worn out, not used up, or as I think Jana pointed out, they're social capital improves through, actually I forget who pointed out, social capital improves through use, natural capital is restored by sunlight. They can only be used at a fixed rate over time. They can't be stockpiled. That would be capital and labor, and it would be ecosystem services and solar energy. And just to give the example of a pizzeria, and I know they say that we've moved beyond this, but I'll give an example. A pizzeria, the stock flow is the raw materials for making the pizza. The fund service is the cooks and the ovens. They are non-substitutable. They are complements, not substitutes. And it's one of the things, the limits to substitution is these and these are complements. You need raw materials to make things. You can't, no matter how many boats you have, it doesn't matter if there's only one fish left in the ocean. So to say, okay, well, economists don't really buy that. Here's a quote from a Nobel Laureate from a 2007 paper. It's still online. It's the economics of greenhouse gases, and it's about substitution. He says agriculture and forestry are less than 3% of total output of the economy. Little else is much affected by climate change. Even if agricultural productivity declined by a third over the next half century, the per capita GNP we might have achieved by 2050, we would still achieve by 2051. Have 1/3 less food, but who cares, because everything is measured in dollars. $1 is as good as another. Everything is perfectly substitutable. So this is a Nobel laureate, has this online, and that's, in my view, is a little bit of the weak sustainability paradigm. In contrast, the strong sustainability paradigm, here's Aldo Leopold. The last word in ignorance is the man who says of an animal or plant, what good is it? If the land mechanism as a whole is good, and this is, in my view, the life-supporting functions of ecosystems, as a whole is good, that every part is good, whether we understand it or not. If the biota in the course of eons has built something we like but do not understand, which we certainly do not, then who but a fool would discard seemingly useless parts? To keep every cog in wheel is the first precaution of intelligent tinkering. So in my view, this is the strong sustainability argument. The other idea that we can do without half of our food is the weak sustainability argument. And so now actually, I think I can't really have time to go into maybe just 2 slides on human behavior. Because I think it's really important, but I don't want to take up too much time, only time for questions. The big thing in human behavior is conventional economists have modeled us as rational, competitive, and self-interested. Other question is, are we instinctual, cooperative, and altruistic? And my view on this, and I mentioned this to people earlier, and there's really good evidence of this. So the rational mind evolved actually a fairly short time ago in evolutionary terms. And we still make most of our decisions instinctually and emotionally. And they've done these really cool studies to show that we make a decision using the emotional part of our brain and then rationalize it. And they've done really cool studies, if anybody wants, I can talk about them afterwards, with split brains that conclusively show we rationalize our decisions after the fact. So we really are driven by instinct and emotion. And this really explains why people buy into certain political views or religions and everything. But this is just Milton Friedman saying the world runs on self-interest, and then here's a barn bowling cooperative and a bunch of headlines from this year. Teens rush into house of fire, save lives of 8 children. Soldier dies in Bronx trying to rescue others. The whole point is that we really are. We have both. The interesting thing is that this debate has run in parallel on economics and evolution. So nature, red and tooth and claw, we're purely competitive. If you help others, you're going to lose out. That was the capitalist version of evolution. At the same time, Kropotkin in Russia was actually saying, no, it's extremely cooperative. Animals help each other. And you've had these ups and downs within evolutionary theory and economics about whether people are innately cooperative or competitive. I would argue, and I don't have time to talk about this, we're the most social of animals. There's a book called Super Cooperators that explains a lot of this, written by Michael Nowak, publishes regularly in Science, really esteemed scientist. And that rationality for a social animal, we cannot survive independent of our society. The most rational thing we can do is be part of a social system. And how do you be part of a group, of a social system, is you have shared myths. I agree with my shared myths of my community, they accept me. Those shared myths can be totally flawed. It's rational to believe in them if that's going to allow you to survive. So we really need to think of people as persons in community, not methodological individualism, and that behaviors can be affected by social norms and institutions. And really quickly, I'll go these last 2 slides. I just wanted to say that I said earlier that methodological individualism was associated with neoclassical economics. And here's the definition of it: amounts to the claim that social phenomena must be explained by showing how they result from individual actions. So large-scale things are explained by small scale with no emergent phenomena, no complexity. And this is, 2015 article, Stanford Encyclopedia of Philosophy. It has never escaped anyone's attention that the discipline that most clearly satisfies the strictures of methodological individualism is microeconomics and the tradition of neoclassical marginalism. So I just wanted to say that when I assert some of these things, I'm not just blindly I'm not attacking a straw man. And then these are some news stories. If anybody wanted to look at it, I can make this stuff available, about how money affects morality. The simple idea of money changes the way we think, weakening every other social bond. Money sows mistrust, it ends friendships. These are research articles in the paper, and these are research articles in journals. And what they convincingly show is that studying economics makes people more selfish and less cooperative. The big question is whether it's selection or indoctrination. Do more selfish people tend to do economics programs, or does studying economics make you more selfish? And these are widely replicated studies. So this one is, does studying economics inhibit cooperation? Why are economists different? And then there's really good research on money that shows the same. But the basic point is, actually I'm going to do this one last thing. So the central goals of ecological economics are, I said, ecological sustainability rules out endless growth. Just distribution rules out valuation that weights preferences by purchasing power. So just distribution, we can't give people with more money more say. So our conventional valuation techniques are not very good. Allocative efficiency, we redefine it as minimizing the ecological cost of satisfying basic needs. So here's another paper I'm just finishing right now based on another research article. Here is one slide from it. And what this is countries arranged from poorest to richest. This is a econometric estimate we did of the elasticity of demand. So when the price of food goes up by 1%, by how much do those countries decrease consumption? And so you see that the poorest countries, a 1% increase in price of food leads to a 0.78 decrease in consumption, because they're spending 80% of their income on food, and when it goes up by a small amount, they can't really, they can't afford more. The richest countries have no impact. When the price of wheat tripled in the United States, consumption actually went up. So what we see is, and what this shows is the per capita caloric consumption in countries ranging from poorest to richest. So what we see is the market, magic of the market. Price of food goes up. These people have to slash consumption. The poorest people consuming the least amount of calories, barely meeting their basic needs for calories, have to slash consumption. The richest people consuming so much it's making us ill aren't affected at all. So so basically it's this market efficiency is demand, demand is preferences weighted by purchasing power. The preferences of the poor weighted by their negligible purchasing power, preferences of the rich weighted by their huge purchasing power. So we have a market demand curve. I showed before that rich people are here consuming too much, but if we're looking at prices, poor people can only afford to buy food when the prices are low. As prices go up, middle class can still afford to buy food. As prices get really high, the rich do. The point is that markets are allocating food to those who need it least. And the implication here is that markets systematically allocate essential resources to those who need them least. And that's what economic systems have to get right, is essential resources. And I'll cut now, and this is just a quote from an economist I like a lot, Uwe Reinhardt, who is trained. He's a Princeton economist. So, but he says, in my view, when economists wax mushy on the virtue of what they call efficiency, it's time to run for the hills, for they're selling a preferred moral doctrine in the guise of science. And I have a bunch of conclusions and stuff, but I've talked enough. I have other projects I didn't have a chance to get to, but I think I have enough controversy for one presentation, probably. And I want to give people time for questions. And I apologize if I talk too fast for people to actually absorb concepts. But.
Questions or thoughts?
I wonder if you could go back to that last slide, the one with the graph.
Yeah.
Or the city.
Oh, yeah.
So I guess my question here, and maybe I'm thinking too narrowly in the U.S., but it seems like we have the cheapest food
right.
in the history of mankind. We 10 cents on the dollar goes towards food, but I guess that's because we're at the upper end of this.
It's actually 10 cents on the dollar goes towards all food. If you're looking at food purchased for home consumption, it's 6.7 cents on the dollar. And if you're looking, and that is about 90% packaging and middlemen. So if you're looking at raw food, it's like 1% of our income. And whereas these people are buying primarily raw food and spending 80% of their income.
So I guess, and this isn't tension with what you said, but when I think about food shortages, I think about the U.S. primarily, and obviously it's a much bigger problem in other places, but it seems like the supply of cheap food is a bit of an issue with nutrition as well.
Yep.
And so maybe
that's huge important.
Ends of the side of the graph and not necessarily at the bottom left side.
Right. Yeah. And so actually, so around the world now, obesity is skyrocketing in Africa. So so malnutrition is inadequate access to macronutrients or inadequate access to micronutrients. And more now, it's inadequate access to micronutrients. So you can be obese and malnourished because you're not getting, and ironically, in the United States, we only subsidize unhealthy food. So just last Farm Bill, they made it that if you're growing, before that, if you grew any healthy food, you couldn't get crop insurance. Now you can actually grow 15% fruits and vegetables and still get crop insurance on your remaining unhealthy foods.
It's all commodity.
Yeah, it's all commodity crops. So, and there's things here that's anomaly. So we actually, this is a very, very complicated econometric estimate with mind-numbingly complex. I did it with a grad student in Portugal. But it's using geometric mean price. And because rich countries, the price of food is relatively cheaper than in poor countries relative to everything else. So using geometric mean price, it actually shows that in the richest countries, we're decreasing consumption as the price goes down or increasing consumption as the price goes up, which doesn't make any sense. It's an artifact of the model we use, which is an artifact. It's a World Bank database. But yeah, extra.
There's a lot of within-country variation. What would this graph look like if it
That's
showed
error bars.
Part 2 of our research, we do have all the data on Gini coefficients, and so Angus Deaton, I guess is his name, just went through the U.S. He's last year's Nobel Laureate, now is like on food security or something at the UN, went through the U.S. He said that, documented really serious poverty and malnutrition in the U.S. And so really what you would expect is that, in the U.S., the poorest people are here. And in the Congo and Eritrea, the richest people are here. And so we would like to break it down into a more fine-grained analysis. And it's complicated. I mean, this is like, and even here, there's huge errors. Like this data here, a lot of this data on caloric consumption, it's self-reported. I trust this like very little. But overall, I think the trend line, there's huge dispersion that I would say probably 80% of that dispersion's poor data. I'm pulling a number out of my ass when I say 80%. But,
So Alina and I have a project, and one of the challenges, it's a project that I really want to work on. Alina has been kind of humoring me, and kind of her point is that.
And now you're putting her on the spot.
No, I'm not. I really won't. But part of her point is that the economic theory is poorly situated to deal with what happens when you have failed real estate markets, and so we're trying to figure out how to do that. So by comparison, or using that as an example, is part of your point in the terms of ecological economics is, I'm trying to distill down into the essentials.
Yep.
Is that we need economic theory that accounts for our ecological understanding, and
our lack of understanding as well.
And lack of understanding. So there's a part of your argument that's, I think, about now that we understand the ecology of the world, here's what we should do. There's a normative piece, but there's also, I think, what the point was, the positive point, which is we need to rethink how we do economics, how we do optimization, how we do think about efficiency and whether or not we have equilibrium because of how we now understand ecological systems.
Yeah.
So is that so? You have sort of, is there an argument that here's our approach to economics before under ecological understanding, and here's where we need to go to because of ecological understanding?
And it's not just before ecological understanding, it's before we were butting up so hard against ecological constraints. So even if we understood the ecosystems perfectly in Adam Smith's time.
The second point is the normative statement.
The second point that we're butting up against ecological constraints?
Is I think that's a normative statement. The preceding part is a positivist statement. Like, even if we weren't butting up against those things, maybe because of our new understanding of ecological systems would cause us to rethink how we approach economics.
Yeah, and so again, my view is, and as I tell all my students, that the worst thing they could do is to buy into this paradigm as though it's the be all and end all, because our system's going to evolve. There'll be new constraints, new limitations, new ways our systems have to evolve to address the new problems.
Right.
And I look at it as the positive. If we believe these ecological ecologists, it's a fact that we are threatening to surpass ecological thresholds. We don't know quite where lie. It's normative to say that that's a bad thing. Because as I say, like we could go out and we could just, we go out in a blaze of mediocrity. We could just like burn through all the resources and. And what I didn't get to in this is, in my view, most of the challenges we now face are prisoners' dilemmas, and prisoners' dilemmas are best solved through cooperation. And we evolved to be the most cooperative species, and we can create institutions that stimulate cooperation. And rather than trying to think about things as market failures, we should be thinking, well, markets are one institution that work on some situations. We need to develop whole new institutions based on cooperation. And I really think I do think that there is really room for rapid change, where we quickly see, and especially with information, we quickly see that information improves through use. And that's why I use this story of transitioning from fossil fuels that can be privately owned and use, you got to compete for use, to solar energy, which is private ownership is kind of silly, and the knowledge required to capture it is improved through use, and the value of the knowledge is improved when it's free, because if everybody has free access to this knowledge, then they will use it and we won't get runaway climate change. So if I use prices to ration access to the knowledge, I will decrease its value. And so the market in this case minimizes the value of the resource. Doesn't minimize it, but it dramatically reduces it, which raises the question of how you actually develop those technologies.
Oh, sorry. Sorry to cut people off, but we do have to start the